Assalamu alaikum students. Today we're going to proceed on the next topic, which is liquid extraction. So now let's proceed to the definition and application of liquid extraction. Okay, in this liquid extraction, so you need to know the definitions involved. So it's involved the transfer of constituents, or you call it solutes, of a liquid solution by contact with another insoluble liquid. So we can see here that there must be two types of liquids involved. Okay, one is the solutes in your feed mixture, and then another one is called solvent. So another insoluble liquid represents solvent. These two types of liquids, which is your liquid solution in the feed and your insoluble liquid, which is your solvent, will be in contact with each other to get the product. The product is called extract liquid and raffinate liquid. In liquid extraction, the transfer is based on the preferential solubility of solutes in the liquid solvent. So we would like to know that we have to make sure that in order for the solutes to be transferred into the liquid solvent, we must select the proper solvent to be used in the process. The two phases must be immiscible to each other, or maybe partially miscible to each other. So these particular liquid extractions normally involve in the food processing, pharmaceutical separation, and oil purification. These are the principles of liquid extraction. So we have solution, which consists of components A and B, is mixed and agitated with the solvent C. So the solution represent the feed solution that you have. You can have a component A, component B, component C in your feed solution, but one of them, so let's say we're going to assume that A is our solute in the solution. We want to separate solute A from this particular solution. So it needs to be mixed with solvent C. Okay, so the intermediate solution will be formed at which a lighter liquid bubbles through a heavy liquid. So we can see that if this is the case, the intermediate will settle into two distinct liquid layers, which is called solvent rich, which is your extract, and diluent rich, which is called your raffinate. So by looking at this, we know that the extract and the raffinate will be the product of your liquid extraction process. Mass transfer occurred when the solute A in your solution transferred into your solvent C. Okay, so in this case, a separation takes place when the solute can be transferred into your solvent. In most of the cases, there is a certain limit to how much your solute could be dissolved in B and C. So that is represented by triangular diagram. Okay, now let's look at this simple picture. Okay, so we can have, in this picture, you have a mixture of liquid, all right? But your mixture of liquid here consists of your solution, which is your feed solution, and it also consists of your solvent. Okay, so you mix your solvent together with your liquid solution, and then you're going to agitate or mix or stir. Okay, and then you're going to leave it a little while. Later, you're going to separate your product. So this is your product, and your product is called extracts. And then you have another product, which is called your raffinate. So you can see that in the liquid mixture that you have, it consists of your solute represented by the red color circle here. And your objective is to separate this solute from the rest of the other compounds or other species. Okay, so to achieve that, we're going to use liquid-liquid extraction. We cannot separate a liquid mixture or species in the liquid mixture using physical separation. So the only way to do this is using liquid-liquid extraction, where you select your solvent which can extract your solute to be separated. This is another picture where you can see the demonstration of the liquid-liquid extraction. So these are the liquid that you have, okay, the liquid solution that you have. So in this liquid solution, it consists of your species, maybe species A as your solute, and then you can have another species B. So let's say you have a mixture of A and B in this solution. Then you're going to add your solvent. So normally solvent is lighter, okay, so that's why it is on the top of this beaker. So after you select your solvent properly, okay, because the transfer of your solute to your solvent is based on the preferential definition that we have described before, okay. Then you're going to mix these two solutions, okay, using agitator or stirrer, okay. Let them mix, okay. And then after you mix the both solutions, you're going to let it settle for a while, and then you can see that you have two products already here. So this is where you have your solvent. Before this, there's no solute inside. So after the agitation, the solute is attracted to the solvent and leave the rest of the species in the solution mixture at the bottom of the beaker, okay. So you can see you have two layers here. One is called your extract, another one is called your raffinates. So later you're going to separate both, okay, separate them both so that you can only get your extract and then you get your raffinate. So this is where you call this product as extract rich product, okay. So you have all your solvent here together with the solute. So this product will be further processed. Maybe you would like to process it using a distillation column or so on, okay. So normally this is the basic process that you have in the liquid extraction. Later you're going to extend the process to separate the extract and the solvent, okay. So this might be can be achieved using distillation column. All right.